Hello, just a second. ಇದಾಗ್ತಿಲ್ಲ ನಿಮಿಷ. So, in the last class we discussed about the equivalence testing. ನೆನ್ನೆ ಯಾಕೆ ತುಂಬಾ ಜನ ಅಬ್ಸೆಂಟ್ ಇದ್ರಲ್ಲ? Only Suraj and Nikhil have joined. ಶರಣ್ಯ ಯಾಕೆ ನಿನ್ನೆ ಜಾಯಿನ್ ಆಗಿರ್ಲಿಲ್ಲ ಕ್ಲಾಸ್ಗೆ? ಸೊ ನಿನ್ನೆ ಥಿಯರಿ ಎಲ್ಲ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ದೀನಿ. ಇವತ್ತು ನಾನು ಜಸ್ಟ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಎಕ್ಸ್ಪ್ಲೈನ್ ದ ಎಕ್ಸಾಂಪಲ್ಸ್ ಆಫ್ ಡಿಫ್ರೆಂಟ್ ಟೆಸ್ಟ್ ಕೇಸಸ್ ಫಾರ್ ಡಿಫ್ರೆಂಟ್ ಈಕ್ವಲೆನ್ಸ್ ಕ್ಲಾಸ್ ಟೆಸ್ಟಿಂಗ್ ಸ್ಟ್ರಾಟಜೀಸ್. ನಿನ್ನೆ ನಿಮ್ಗೆ ಥಿಯರಿ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂತಂದ್ರೆ ಇವತ್ತು ನೋಡಿ ಕಷ್ಟ ಆಗುತ್ತೆ. ಯಾಕೆ ಜಾಯಿನ್ ಆಗಿರ್ಲಿಲ್ಲ ಉಳಿದವರು? So in the last class, I started with the equivalence class testing. In that I explained why we are going for the equivalence class testing, what were the limitations of boundary value analysis testing. And after that, I explained what are equivalence classes and how to construct the equivalence classes. Then I explained the different equivalence class strategies. So first one is the weak normal equivalence class testing, and second one is the strong normal equivalence class testing. After that, we have discussed about the weak robust equivalence testing and the strong robust equivalence testing. So this is the weak robust equivalence class testing, and then next one is the strong robust equivalence class testing. These type of testing strategies that we discussed in the last class. So today we are going to you're going to study about the construction of the test cases for the triangle problem, next date function problem, and the commission problem. These test cases we are considering for the equivalence class testing. Okay, so first we'll start with the triangle problem. So as we already discussed that in the triangle problem, we will have the 4 possible outputs. What are those? So we'll first 3 will be uh, the types of the triangle, that is whether it is equilateral, isosceles or the scalene triangle, and the fourth type is it is not a triangle. So so for this we have already discussed the triangle problem in the second chapter itself, right? And what are the possible inputs for ABC, where ABC are the slides of the triangle that we discussed already, right? So we are here we are considering the same example, that is the triangle problem example, and we are going to construct the test cases for the equivalence class by using the equivalence class testing. Okay, so first we'll see the problem statement for the triangle problem. See, in the problem statement, we know that 4 possible outputs can occur. One is the not a triangle, that is the case, and other 3 types are the types of the triangle, that is the equilateral, isosceles, or the scalene triangle. And we can use these to identify the output or the range equivalence classes. So we are considering all 4 possible cases. First one is the R1. If A, B, C are equal, then we say that it is equilateral triangle. And the second case is R2. So in the alt, we are considering the isosceles triangle. So when it is isosceles triangle, if 2 sides of the triangle is equal, then we say that it is a isosceles triangle. So second test cases we are defining that R2 is equal to ABC, the triangle with sides AB and C is isosceles. So here we'll say that isosceles when 2 of the sides are equal. And the third one is R3 is equal to ABC. Here the triangle with sides ABC are scalene. Scalene means each of the side is not equal to other 2 sides, means all the sides of the triangle are not equal. Then we say that the triangle is a scalene triangle. And if not all these 3, then we say that the triangle is not a triangle, or we cannot construct the triangle. So that is the fourth one, that is R4 is equal to ABC, sides of ABC do not form a triangle. So whenever we are using the ABC to construct the triangle, if it is not possible, then we have to display the message as it is not a triangle, or it is not possible to construct the triangle. So these are the 4 possible cases we are considering. So first we'll see the type of equivalence class. So first we'll consider it for weak normal equivalence class. Next we'll consider it for strong normal equivalence class testing. Next, other two are the weak robust equivalence class testing and strong robust equivalence class testing. So first we'll consider it for the weak normal equivalence class. So what are the test cases for the weak normal? So four test cases are defined here with the sites A, B, C, and what will be the expected output. So here we are constructing the test cases based on the expected output which is given in the problem statement. So in the problem statement, they have given that by giving the sides of the triangle ABC, we have to define whether it is a triangle or not, and then type of triangle, scalene, isosceles, and equilateral. By considering this expected output, we are constructing the four types of test cases. One is the weak normal test case 1, next one is WN2, WN3, and WN4. So first one is WN5. The expected output is equilateral. When the expected output is equilateral, when A, B, C are equal. So if A is equal to A is equal to 5, B is equal to 5, and C is equal to 5, we say that it is a equilateral triangle. So here the value is not necessary 5. You can consider A is equal to 10, B is equal to 10, C is equal to 10, or A is equal to 100, B is equal to 100, and C is equal to 100. So the condition is all the sides value should be equal. Then we say that it is a equilateral triangle. That one test cases is constructed. And the second one is weak normal test case 2. Here we are constructing the test case for the isosceles triangle. So when we say that it is isosceles triangle, when if any two of the sides are equal, then we say that it is an isosceles. So here we are considering the example of A is equal to 2, B is equal to 2, and C is equal to 3. Since here A and B are of equal value, then we say that it is an isosceles. Next, we'll consider one more test case for the scalene. So here A is equal to 3, B is equal to 4, and C is equal to 5. Means none of the sides are equal to other two, right? So each side is having the different value, then we say that the triangle is a scalene triangle. If not these three cases, then the last one is the not a triangle, because if B is equal to 1 and 4 is equal to 4, A is equal to 4 and B is equal to 2, we cannot construct the triangle, or it is not possible to construct the triangle. Then we say that the expected output will be a not a triangle. Okay, these are test cases we are considered for the valid variables. Okay, we are constructed the test cases for the valid variables. Valid variables means what? So the value we are chosen for ABC belongs to the value which is given within the range, or they resides within the range. So what are the ABC values? There they have defined the way is ABC are ranging from 1 to 200. If we give the values within that range, then we say that those are the valid values for the variables A and B. And if the range is, or if we give the value for A or B, C as more than 200 or less than 1, then we say that it is the invalid value, because in the problem statement it is specifically asked to construct the triangle for the given values of ABC, where ABC values are ranging from 1 to 200, right? So if we give the value more than 200, then it is treated as the invalid value, or if we give the ABC value less than 1, then it will be treated as the invalid case. Okay, so hence here we have constructed the test cases for the weak normal equivalence class by considering only the valid values of ABC. Okay, next we'll consider for the invalid values. So here, so no valid intervals of variables ABC exist, then the strong normal equivalence class test cases are identical to the weak normal equivalence test cases. So here we have the same test cases for the weak normal as well as strong normal test cases. Next, we'll consider for the invalid values. See here, in this example, we have not considered the invalid values. For all the test cases constructed only for the valid values. Next, we'll consider it for invalid values. Invalid values, as I said, if any of the ABC value is less than 1 or greater than 200, then we say that it is a invalid value. Okay. So here, when we are considering the invalid test cases, here we are considering it for weak robust test case. Okay, so in the weak robust test cases, because here the two parts are there, as I explained in the last class, weak robust and strong robust equivalence test cases are constructed by considering the two parts. One is the weak part and the robust part for weak normal. Similarly, for strong robust, one is the strong part and the other one is the robust part that we are considering, right? So here we are considering it for weak robust equivalence classes test cases. So here the six different test cases are identified, which consisting of the invalid values also. Okay, see here, so all the test cases that we have defined for invalid values. Okay, so first, let us consider the first one. First test case, A is equal to -1, B is equal to 5, and C is equal to 5. Here, B and C are within the given range, but A is equal to -1, that is not within the range, because the value should be within 1 and 200. If other than that, it will be considered as invalid. So, the way value of A is equal to -1 and that is treated as the invalid value, then what will be the expected output? Value of A is not in the range of permitted values. Similarly, if you consider it for B, that is -1, then B is not in the range. And for the third case, it is -1, then we say that it is C is not in the range. Similarly, we are so here we are considering the A value which is less than the minimum value, right? A or B or C. For first three cases, we have considered the values which is less than the minimum value. Next three cases, we are considering the values of A, B, C which are greater than the given range. Okay, so A is equal to 200. In the fourth test case, A is equal to 200, 201 is given. So if this is the case, then once again it will display the error message as the value of A is not in the given range. Why? Because for A, the range is given is from 1 to 200. More than 200 will be treated as the invalid value, or it is not in the range. Similarly for B and C also. So for B it is equal to 201 and for C also it is 201. These three values are not in the range, and hence for these three test cases we are considering that A is not in the given permitted range and B is also not a range of the permitted values and C is also not in the range of permitted values. So these are the different test cases we have constructed by considering the invalid inputs or invalid values for the variables A, B and C. Next. Next, we'll consider it for the strong robust equivalence class test cases. So what is the difference between weak robust and the strong robust? In weak robust classes, we are considering the robust value along with the assumption of single fault assumption, right? But in the strong robust, we are considering the multiple fault assumption test cases, and hence more number of test cases are constructed for the strong robust equivalence class testing. So here test case is given -1 for the strong robust. It is A is equal to -1, B is equal to -1, C is equal to -1. Along with that, we are considering the one more case, that is A is equal to -1 and B is equal to -1, or B is equal to -1 and C is equal to -1, or AB. Means here we are considering the Cartesian product of all the possible test cases. All possible test cases means first we are considering A into B into C, next A into B, next B into C, A into C, like that. That's why we are only for these three. That is the -1 value. We have seven different test cases. Means so see the example in the previous case we have only the 6 cases and 3 for the value which is less than the minimum, and 3 more test cases for the value which is greater than the maximum value that we have considered, right? So total we got only 6 test cases in the weak robust equivalence class testing case. But here you consider the a strong normal. As I said, in the strong normal we are considering the multiple fault assumptions ABC, right? So hence we will have more number of test cases. ಸೈನ್ ಆಮೇಲೆ ಮಾಡ್ತೇನೆ ನಾನು ಕ್ಲಾಸ್ ಮುಗಿಸ್ಕೊಂಡು ಒಂದು ಅರ್ಧ ಗಂಟೆ. So we have more number of test cases for the strong normal equivalence class testing strategy. So here we are considering the invalid values for A, B, C, where A, B, and C are less than the minimum value. Similarly, if you construct it for greater than the minimum, greater than the maximum value, then one more test case will be SR8, that is A value is equal to 201 and B is equal to 5, C is equal to 5. Similarly, we'll have one more test case, that is A is equal to 5, instead of B, instead of -1, we'll consider it as 201 and C is equal to 5, and for C it is 201, like that. Once again, we will have 7 more test cases for the invalid values which are greater than the maximum. So here 7 test cases are constructed for the invalid values where ABC values are less than the minimum, -1, -1, -1, because minimum value for ABC is 1 and the less than 1 will be treated as the invalid case, right? So hence we will have 7 test cases for this. Similarly, if we consider the greater than the maximum value, then we will have 7 more test cases. So hence, whenever we are using the strong, robust equivalence test classes, then we will have more number of test cases, or in that we are going to construct more number of test cases. Why? Here we assumes that we are performing the Cartesian product of each of the variable, and for all the combinations of the Cartesian product, we are defining the values. And why we are going for that? Here we assumes that whenever we are performing the strong equivalence testing strategy, or whenever we are using the strong equivalence testing strategy, we'll say that the testing is complete, or it leads to the completeness of the testing. Okay, why? Because we are considering each possible test case. So equivalence class testing is sensitive to the equivalence relation used to define the classes. So if equivalence classes are based on the output domain, then we will have the more number of test cases, or richer set of test cases are obtained. And here some of the possibilities of for the 3 integers ABC are given, and ABC may be equal or not equal. So first one is the first case, D1 where ABC, where A is equal to B is equal to C. And for the second case, A is equal to B, but A is not equal to C. This indicates that only A and B are equal and C is not equal to A and B. And the last one, third one is ABC, where A is equal to C and A is not equal to B. And the fourth case is B is equal to C, but A is not equal to B. And the last one is none of the sides are equal, right? A is having different value, B is having different value. Similarly, C is having different values. So here for these 3 integers, A, B, C, or if we consider, if we treat these as 3 variables in the triangle problem, then according to that, uh, we are defining the test cases. Next, apply the triangle property to see if they even constitute a triangle for the example 1, 4, 1. Okay, so even in this case 1, 4, 1 means what? A is equal to C and B is having the different value. But according to the definition, then this leads to the what type of isosceles triangle. But even if we give like this, the triangle cannot be constructed when we are using the value 1, 4, 1, because if we consider B as the base and A and C are the sides of the triangle, then we cannot construct the triangle just by using the value 1 and 1 for A and C. And hence for this, they will consider that it is not a triangle. And because here the condition is given, right? D6, D7, D8, for this the condition is given, A is greater than or equal to B plus C. But here if we consider this, what is the A value? 1. What is the B and C value? 5. Whether 1 is greater than 4 plus 1? No. Then if this condition is not satisfied, then we say that it is not a triangle. Similarly for B and C. So B also should be greater than equal to A plus C, and C should be greater than or equal to A plus B. Then only it is possible to construct the triangle, otherwise not. Hence, for the given combination 1 4 1, we cannot construct the triangle, and hence the expected output will be it is not a triangle. So for this, three more test cases are defined for not a triangle case, right? Next, separate the greater than or equal to into the two distinct cases. Then we will have the one more test cases for the D6, where D6 is divided into D6 dash and D6 double dash. Okay, understood? Hello, hello. ಹೇಳಿಪ್ಪ. ಹ್ಮ್ ಹ್ಮ್ ಹ್ಮ್. Understood? This one? Yes, Suraj, Sharanya.
Yes, ma'am.
Understood. Yes, Suraj.
Yes, understood, right?
Yes, ma'am.
Shall I go to the different test case? Okay. So here D6 is divided into D6 dash and D6 double dash. Why? Because in the D6 we have considered both the cases. A is greater than or equal to. If we divide it into two, that is A is greater than and A is equal to, then we will get two more test cases. That is for ABC, A is equal to B plus C, and the other one is A is greater than B plus C. Okay, that also we can write. Similarly, for D7, D7 is divided into two more test cases, D7 dash and D7 double dash. For that, B is equal to A plus C and B is greater than A plus C. Similarly, for D8, we can construct a more number of test cases. Okay. So this is about the construction of the test cases for the triangle problem by using the four different equivalence class strategies. So what are those four strategies? One is the weak normal test case or weak normal equivalence class testing. Second one is strong normal equivalence class testing. Third one is the weak robust equivalence class testing. And fourth one is the strong robust equivalence class testing. Okay, so this is about the construction of the test cases by using the equivalence class testing strategies for the triangle problem. All of you understood? Yes, construction of the test cases by using the equivalence class testing. Any
Yes,
doubt?
ma'am.
Okay, so
Yes,
no
ma'am.
doubt, then I'll move on to one more example, that is the next date function. So in the next date function, that problem we already defined and explained in the second chapter itself, right? So what this problem says, whenever you will give the particular date, then it will display the next date, right? So for that, we will have the conditions or the valid values are defined like this. For the months should be from 1 to 12, and the days should be from 1 to 31st, and year also is defined. The range is defined for the year also. There we have considered it from 1812 to 2012, right? So if the value or the year value is greater than 2012 or less than 1812, that will be treated as a invalid value, right? Similarly, for the month, if the month is less than 1 or greater than 30, it will be treated as invalid cases. And for the year, if it is greater than 2012 or less than 1812, that is treated as the invalid equivalence class. So here, three are defined for the valid equivalence class and six are defined for the invalid equivalence class, because here we are considering both the minimum and maximum value for each of month, year and date. So this is the condition. M1, D1, Y1 is for the valid equivalence classes, and the remaining M2, M3, D2, D3 and Y2, Y3 are for the invalid equivalence class. This is easier, right? You can easily construct it by using the given problem statement, right? Construction of the valid equivalence class and construction of the invalid equivalence class. Okay, any doubt here? Construction of valid equivalence class for the next date function? Yes? Okay.
No, ma'am.
Okay, next we'll continue. So we'll see the number of valid classes equals the number of independent variables, and hence only one weak normal equivalence test case is we have constructed, and it is identical to the strong normal. So whenever we are constructing the weak normal or strong normal test cases, normally the number of test cases will be equal for both the weak normal and strong normal test cases. So we'll see one test case, which is we are constructing the test case by defining the values for the variables month, day, and year, where these values are uh, resides within the given range. So weak normal WN indicates it's a weak normal, 1 indicates it's a test case 1. Similarly, SN1 means strong normal test case 1. So month is 6, day is 15, and year is equal to 1912. This is the value we have given for month, day, and year. What is the expected output? So by using the next date function, we are displaying the next date, right? So if today's date is 15 and 6, present month is 6, and the present year is 1912, then what will be the next day? The next day is 16/6, means 16 June 1912. This is the expected output. So since we have given the invalid values for the month, day, and year, and hence we are getting the correct expected output, that is 6 16 1912. This indicates that the 16th June 1912. So this is the test case that we have constructed for the next date function by using the weak normal and strong normal testing strategy. Similarly, we can construct the test cases by using the weak robust testing strategy. So there we are considering the invalid values for the month, day, and year. Right. So first one is the weak robust. Um, this is the normal test case that we are considering 6 15 1912. We are getting the expected output because the values are within the range, right? And the second test case for the month, if we give it as -1, then what it will give? So because month should be between 1 and 12, then it leads to the erroneous output. Then it will display the error message as the value of the month is not in the range. Why? Because the range is from 1 to 12. And if it is -1, then it is not in the range. That error message will be displayed. Or if we choose the month value as 13, then also it will display the error message. Why? Because the range given is 1 to 12. More than 12, it display the error, or less than 1 also it will display the error. Similarly, for the day, it is -1. Is -1 there in the days? No, right? The range is from 1 to 31. So within that range we have to give the values for the day. Other than that, it will display the error message. So for -1, it will display the error message. Similarly, for 32, it will display the error message. Why? Because the maximum number of days exist in a month is 31. More than 31, it will display the error. Similarly, less than 1 also, it will display the error message. Next, we'll consider it for the year. So here, there we have defined the range from 1812 to 2012. Other than that, it will display the error message. So if it is 1811, so it will display the error messages value is not in the range, because we are considering the range from 1812. Less than 1812, it will display the error message. Similarly, for 2013 also it will display the error message. Why? Because we have given the range as 1812 to 2012. So hence, the whatever the values here considering here, depending on the value whether it is within the range or not in the range. If it is in the range, we will get the correct output. Otherwise, we will get the error message. See here, 6 different test cases are constructed for the invalid values. Right? 2 for each month, day, and year. 2 invalid values for month, 2 invalid values for day, and 2 invalid values for the year. So in this way, we can construct the test cases by using weak robust. If we consider for the strong robust, then we are getting more number of test cases. Robust equivalence class. So month, day, and year. So here we are considering it for the strong robust. Once again, we are defining the invalid for month and day combination, and month, day, and year combination. See here, -1, and 1811. It is the invalid value for the month, day, as well as for the year. So all three are the invalid values. It will display the error message, and the remaining six that are treated as like this, okay, because in the weak robust we are considering one test case or the two test cases for each month, day, and year, but here we are considering the Cartesian product of month, day, month, year, and month, day, and year. So first it is single month and single day, single year. Next we'll consider the Cartesian product of month and day, hence it is -1 for both. And next one is from day and year. See, -1 and 1811, both are the invalid values. Next one is for month and year, that is -1 and 1811. And the last one is for all three, that is month, day, and year. It is -1, -1, and 1811. So like this, whenever we are using the strong robust technique, we will have more number of test cases. So there we assumes that multiple fault assumptions exist, and hence we are going to define more number of test cases. And once we define the more number of test cases and we are using all those test cases to test the developed program, then we say that by using this particular testing strategy, we can achieve the completeness in the testing. Next, so here it is defined, right? At the end of a month, the next day is 1 and the month is incremented, and the end of the year, the year is incremented and the month is reset to 1. And for the leap year makes the uh, determining the last day of the month. So whenever the leap year occurs, then we have to check for the February month whether 28 days are there or 29 days are there. So first we'll check whether it is a leap year or not. If it is a leap year, then we have to consider 29 days for the February month. So here three conditions are defined for the month which is having 30 days, and the other one is a month which is having 31 days, and the month where it is the February. Why we are defining separately for February month? Because the February month either it consisting of 28 or 29 days depending on the whether the year is a leap year or not. Okay, and once again we will have the number of days. D1 is from 1 to 28 and D2 is 29. Why you are considering 29? That is for the leap year. Next one is D3. It is the number of days is equal to 30, and for D4 it is number of days is equal to 31, because a month may consisting of 28 days or 29 days or 30 days or 31 days depending on type of month and type of year. And next one is Y1. Here it is 2000. 2000 it is a leap year, right? And Y2 here is non-century leap year, and here is a common year. So three conditions we are defining. One is the leap year, and second one is non-century leap year, and third one is the common year. So we'll consider these equivalence classes whenever we are going to construct the test cases. Okay. So that they have explained it once again for 30, 31 and all that I explained already, right? Next we'll move on to the weak normal equivalence test cases. So W1, W2, Wn3, Wn4 for the next date function. So weak normal is simple. It consisting of the normal test cases, right? So we will give the values within the range, if it is more than the range. See here, for the February month, if we specify it as day 30, then 30 days will not be there in the February month, then that will be displayed as a invalid input date, then because that is the error, right? And for the sixth is the June month consisting of only 30 days. If we specify it as 31, then it will display the error message as it's an invalid input date. Similarly, for the strong normal equivalence class, we will have more number of test cases, right? Here, see, strong normal will have more number of test cases because we are considering the Cartesian product of each of the variable. month, day, and month, year, then day, year, then month, day, year. These six are for those combinations. Next six for the invalid input date. Single input, that is any one of the variable is having the invalid value, then it will display the invalid input date. For example, June 6, if you specify it as the 30th, and we are considering the uh, just a minute. Sorry, this is the expected output for 2030 and 6. It is the valid input because month is there 6 June month and 30 days will be there, so it is the invalid, but it is not the invalid input date. It is the valid one, so it will display the next date. Similarly for these three also, for 2000 to 1996 and 2002 also, for all these three, June month consisting of 30 days, so it is the invalid input date. It is sorry, valid input date, not the invalid one. But if we consider it for the day which is equal to 31 for June 6, sorry, June month consisting of only 30 days, for these three test cases or for these three input combinations, it will display the error message as invalid input date. Why? Because June consisting of only 30 days, not 31 days. Hence for these three uh, cases, it is the invalid, or it will display the error message. And next one is the 714 and the 2000, it is within the range, and it will display the next date. If the present day is 14th and the next day is 15th July, similarly for this one 14th 1996 July, then it will display the 15th 1996 July, so it will display the correct date if the valid input is given. Otherwise it will display the error message as invalid input date. So like this we can have more number of test cases for the strong normal testing strategy. So in the strong normal, we are considering all possible test cases for by considering the values for month, day, and year. Next, the last one is the equivalence class test cases for the commission problem. So this problem also I explained in the second chapter itself. Right, so here the salesperson needs to sell the logs, stocks, or the barrels. The condition is given, the salesperson, the condition for the number of logs to be sold by the salesperson is from 1 to 70. If he sells, or if he trying to sell more than 70, it will display the error message. Or if no blocks are sold, then also it is displaying the error message, because the logs is given from 1 to 7, the condition is given, right? And similarly for the stocks, it is from 1 to 80. If more than 80, then it is a error message. Similarly for the barrels, it is from 1 to 90. So the range is given. So only 90 barrels are available, then the salesperson can sell only 90 barrels, not more than that. So these are the valid cases for the logs, stocks, and the barrels. And the invalid cases are the if the log value is equal to 0 or it is minus 1, then it is a invalid test case. And the logs are greater than 70, then also it is a invalid class. And if the stock is less than 1 or greater than 80, then also it is invalid. Why? Because the range is given here. For the stocks, what is the range given? It is from 1 to 80. If it is more than 80, then it is an invalid case, and if it is less than 1, then also it is an invalid case. Similarly, for barrels, the value is ranging from 1 to 90. If the value is less than 1 or greater than 90, then it is considered as a invalid case. So, 4 valid classes are defined and 6 invalid classes are defined. Right, depending on the condition given in the problem statement. So here the test cases are defined for the weak robust and the strong robust in the next slide. So if all are 10 10 10 means the values are within the range, then what will be the expected output for the commission problem? there we are, the expected output will be calculation of the commission, and that will be distributed in the sales percent depending on the sales, right? If the salesperson sells up to $1,000, then he is going to get the 10% commission. If he sells more than $1,000 and less than $1,800, then he is going to get 15% of the commission. And if the salesperson sells more than 1,800, then he is going to get the 20% of the commission. Okay, that is the expected output, right? So here, according to that, the expected output is given, and we have chosen log, stocks, and barrels values. So for the test case 1, weak robust, WR1 indicates weak robust test case 1. For that, we have chosen the values logs, stocks, and barrels are within the given range, and we are calculating the commission. So if we consider these, then the total sales value will be less than or equal to $1,000. Then the salesperson is going to get 10% of the commission. Okay, so the commission is calculated and the commission is distributed to the salesperson. But if we choose the log value as -1, then what happens? Program terminates because the log values cannot be -1. So it is the invalid input and the program terminates. And if log's value is equal to -2, then what happens? The value is not within the range. Why? Because for the logs, the values defined or the range defined is 1 to 70. Other than that will be treated as the invalid value. Okay, so the -2 is less than the minimum value. What is the minimum value? Minimum value is 1 and -2 is less than 1. So that's why it will display the error message. Similarly, we'll consider for the maximum range 71. So what is the value of the maximum range for the stocks? It is 70. 71, it is not in the range, hence it will display the error message. Similarly, for the stocks -1, it will display the error message. Or if it is 81, then also it will display the error message. Why? Because the maximum stocks for the salesperson given is 80, more than 80, then it will display the error message. Understood? Next we'll move on to the barrels. -1, then it is less than the minimum value, then we'll get the error message. Similarly, if it is 91, it is greater than the maximum value, then also we are getting the error message as value of the barrel is not in the given range. Okay. Next, we'll consider for the strong robust. So for the strong robust, we are going to construct more number of test cases by considering the invalid values for the logs, stocks, barrels individually, then the combination of these three. So in the first case, we are considering the individual one. Stock logs -2, it is the invalid one. Stocks -1, then also it is invalid. Barrels, it is -2, so it is the invalid case because the value is not in the given range. Next, we'll consider the combination of two, that is logs and barrels, -2, -1, then also it will display the error message. Next, we'll consider for the logs and barrels, -2 and -1, and also it will display the error message. And the next one is for the stocks and barrels, we are defining the -1, -1 because that is not the valid input, right? And the last test case is we are considering the invalid inputs for the logs, stocks, and barrels, then also it will display the error message. Means in the strong robust, we are going to consider all possible test cases and we are testing the developed program or the system. Okay, so like this we will have for the other test cases, like for the barrels or the barrels, we'll consider it individually. Next, we'll consider it for the stocks or the loss. Like that, we will get more number of test cases, right? So this is for the strong robust. See here, this is for the weak robust test case, and this is for the strong robust. So in the strong robust, we are considering all possible test cases. So they are given the sales, right? If the sales is a function of the number of logs, stocks, and barrels sold. So based on that, we are going to calculate the commission, and the commission will be distributed to the salesperson. So if sales is equal to 45, if sales is equal to 45 logs plus 30 stocks and 25 barrels, then we have to calculate the total sales, right? After that, we have to check the condition whether the total sales is less than or equal to $1,000. If it is less, then 10% of the commission is distributed. If the sales is greater than 1,000 and less than 1,800, then 15% of the commission is distributed to the salesperson. And if the sales is greater than 1,800, then 20% of the commission will be distributed. So for that, we need to check the condition. So here the ranges are defined. For S1, whether the sales is less than or equal to 1,000. For S2, it is greater than 1,000 and less than 1,800. For S3, it is greater than 1,800. So based on that, we are calculating the commission. Understood. So here we will have the output range equivalence class test cases are given logs, stocks and barrels. Then we'll calculate the total sales. Total sales is 500 means he is eligible for 10% of the commission. Then the commission is calculated and distributed. So for this it is 1,800 means it is greater than 1,000 and the salesperson is eligible for 15% of the commission, and 15% of the commission is calculated and it is becomes equal to $175, and that will be given to the salesperson, right? Similarly, we'll consider the third case, 25, 25, 25. Then the total sales is greater than 1,800, then he is eligible for 20% of the commission, and that is calculated and distributed to the salesperson. So these are the output range equivalence class test cases we have considered. Why? Because the range is given, right? 1,000, one range is up to 1,000, second one is from 1,000 to 1,800, and the third one is greater than 1,800. For these three ranges we have defined the test cases. Understood? Any doubt in this? No. Okay. Next, we'll move on to the guidelines and observations for the equivalence class testing. So the first
Ma'am,
guideline
class
says
ಇಲ್ಲ
that
ma'am.
the weak forms of equivalence class testings are not as comprehensive. Within 2 minutes. ಇದು ಇಲ್ಲಾಂದ್ರೆ ಓದ್ಕೊಂಬೇಡಿ ನೀವು, just they have given the guidelines. Okay. If error conditions are high, then the robust forms are appropriate, and equivalence test classing is appropriate when the input data is defined. Then it is strengthened by the hybrid method, and other these are all the guidelines for the equivalence class testing. Okay, this completes the chapter. So equivalence class testing is completed. Okay. So in the next class, I'm going to start a new chapter. That is, in the next class, I'm going to start the seventh chapter. That is the path testing. Okay. So that chapter is also included in the second module. Okay. So so far 3 chapters I completed from the second module. And the fourth chapter, I'm going to start it in the next class. Shall I engage extra class tomorrow? Shall I engage extra class tomorrow, Saurabh?
Yes, ma'am.
Shall I take the extra class tomorrow?
Yes, ma'am.
Tell me the time. At what time you can engage the class? Tomorrow afternoon or what? Hmm?
Ma'am, tomorrow afternoon only, ma'am.
Okay, tomorrow I'll. Afternoon time?
ಅದೇ ma'am 2:30.
Hmm?
ma'am 2:30.
2:30. Okay. Okay, then tomorrow I'll engage the classes at 2:30 or 2:45. Okay. ಸೊ ನಾಳೆ ಮತ್ತೆ ನಾಡಿದ್ದಕ್ಕೆ ಎಕ್ಸ್ಟ್ರಾ ಕ್ಲಾಸ್ ತಗೊಂಡ್ರೆ ನನಗೆ ಟೈಮ್ ಸಿಗುತ್ತೆ ಅಂತ ಅಷ್ಟೇ. ಐ ಕ್ಯಾನ್ ಕಂಪ್ಲೀಟ್ ದ 4th ಚಾಪ್ಟರ್ ಆಲ್ಸೋ.
Yes, ma'am.
Okay, you can leave the class. I'll exit. I'll exit and you can join other classes. Okay. certificate. Yeah, just.